Welcome to Stemming Out, where we solve conundrums in physics.
Physics problem number 1. Frictional forces. A skier is pulled up a slope at a constant velocity by a tow bar. The slope is inclined at 25 degrees with respect to the horizontal. The force applied to the skier by the tow bar is parallel to the slope. The skier's mass is 55 kilograms and the coefficient of kinetic friction between the skis and the snow is 0.120. Find the magnitude of the force that the tow bar exerts on the skier. So here is our given. The mass is 55 kilograms, the mu k or the friction is 0.120 and the degree is 25 degrees. This is in equilibrium because there is no acceleration, meaning all velocities equal 0. So here me and my team will write the problem down and solve it. So to give definition on what frictional force is, a frictional force refers to the force generated by two surfaces that contacts and slides against each other. These forces are mainly affected by the surface texture and amount of force impelling them together. The angle and position of the object affect the amount of frictional force. For example, if an object is placed flat against an object, then the frictional force will be equal to the weight of the object. If an object is pushed against the surface, then the frictional force will be increased and becomes more than the weight of the object. There are different types of frictional forces: dry friction and fluid friction. This problem is dry friction. And here we start our solution. If you look at the given and the problem, you will be able to tell that this will result in a nesting equation, or at least the use of a nesting equation. The first thing we need to do for our solution is to find the y component. Since there is no acceleration, F net is equal to 0. Knowing this, we need to equate n to its counterpart mg so we can use the equation that we find from the y component for the x component. Now that we are able to find what n is, we can now use it for the x component. We use cos theta because we need to find the adjacent side here, which is fg. We find fg because n, or the normal force, should be equal to fg. We then find the x component to find the magnitude of the force that the tow bar exerts on the skier, the tow bar being Fp, or the applied force. Now it is crucial to remember here that the force of kinetic friction, or Fk, is equal to mu k, which is the coefficient of friction that we were given, times n, which is the normal force. So basically the formula should look like Fk equals mu k times n. We then replace Fk with what we have just learned. And by the way, Fg is the force of gravity, while mg is mass times gravity. It is also important to note that the line we drew in between Fg and mg is parallel to the x-axis, meaning if we find this line in between, we immediately find Fp. So to do this, we have to use sine theta because we are aiming to find the line in between Fg and mg, which is opposite to the angle. We then substitute n with what we found in the y component, which is mg cos theta. After this, we factor mg out on the side to make it simpler for us to solve. This isn't necessary, though. We now find our final equation for the applied force, or the force that the tow bar exerts on the skier, which is mg times mu k cos theta plus sin theta. Now that we've found the solution, let us recall what we were given in the word problem. Mass is equal to 55 kilograms, mu k is equal to 0.120, and our angle or slope is 25 degrees. We then replace what we are given and know into our equation. It should come out as 55 times 9.8 times 0.120 cos 25 plus sin 25, which is equal to 286.411, but since it's three significant figures, we put it at 286n. Thank you for watching. Bye bye from me, Z, and Steve.